All right, so section 10.6, we're continuing to look at factoring. Now this time we're looking at factoring trinomials in the form of ax squared plus bx plus c, meaning that no longer is the term or the coefficient in front of the x squared a 1. So now it's some number other than a 1, which makes this drastically more difficult. Now there's a couple of different ways that we can go about factoring these. One of them is kind of a guess and check, which in some cases can be pretty lengthy. So I've got a method that is actually not covered in your book, but I call it the ABC method. And so first thing we're going to do is we're going to find the factors of AC, or A times C. So the first thing we would do to factor this is we would multiply the A term times the C term. Then once we figure out what factors come up to equal the number that we get when we multiply A times C, we try to find the factor that will, or set of factors that will add up to the B term, very similar to what we did in the factoring from 10.5. We make two fractions using those factors of C as the numerators and the A term as the denominator. And this should be actually read as the factors of AC. So whatever factors we came up here, we put those factors over the number that we had for A. Reduce the fraction if we can, but we're still going to leave it as a fraction even if it goes down to 1. We'd leave that as 1 over 1. And then we build two binomials by placing the value in the denominator in front of x, followed by the numerator. All right, so reading through that list of steps may be pretty difficult, but hopefully if you follow along it will make sense. So here we got 3x squared plus 5x plus 2. So we're going to identify A, B, and C here. A is 3, B is 5, and C is 2. So first thing we got to do is figure out what AC is, which is the same thing as saying 3 times 2, because 3 is our A, 2 is our C, and that's going to give us 6. All right, so once we have that A times C term, now we're going to go ahead and multiply those, or we're going to try to figure out what numbers multiply to equal that 6, which with it being a small number like 6, it's not a whole lot of possibilities, right? You have 6 times 1, and we know that they're both positives there, so we're looking at a positive, or both positive factors. So 6 and 1 add together, that's 7. We're actually looking for 5, which actually is 3 times 2, or 3 and 2, which is 5. So 5 here matches the 5 there. So those are our factors. Now 3 and 2 are our factors, but we're going to write those as a fraction over the A term. And what's our A term? It's 3. So write both of them over 3, which is what we're doing right here. Step 3, make two fractions, use the factors of AC as the numerators and the A term as the denominator. Reduce the fractions, but leave as a fraction. So 3 over 3 becomes 1 over 1. 2 over 3, we can't reduce that, so it's just going to stay there. Now once we have the reduced fractions, we're going to build our binomials. So we're going to build two binomials. I'm going to place the value in the denominator in front of x. So here we have 1 in the denominator of this fraction. That's going to go in front of the x. And then we're going to follow that by the numerator, which the numerator here is the 1, and it's a positive 1, so that's plus 1. All right, so our other binomial comes from the other fraction. The denominator goes in front of the x, so that's going to be 3x, and the numerator goes after, and it's a positive 2, so plus 2. And we don't have to write the 1 in front of the x if we don't want to, so this could end up being x plus 1 times 3x plus 2. And there's our factored form. All right, so next one. Same process. Identify A, B, and C. A is 2, B is 21, and C negative 11. So plus minus, we're going to need one positive and one negative, or do our AC. A times C is 2 times negative 11, which is negative 22. And factors that will give us negative 22, we're going to have 1 and negative 22, negative 1 and 22, 2 and negative 11, negative 2 and 11. And basically that's all of our possibilities. So now we add those together to figure out which ones are going to add up to equal positive 21. So 1 and negative 22 is negative 21. Negative 1 and 22 is positive 21. 2 and negative 11 is negative 9. Negative 2 and 11 is 9. So looking for positive 21, which is our B term here. So that is negative 1 and 22. Now we build our fractions. Negative 1 and 22 as our numerators. And those are going to go over our A term, which is 2. All right, reduce the fractions if we can. Negative 1/2, that won't reduce. 11 or 22 over 2 actually become 11 over 1, because 22 divides evenly by 2 to give us 11, but we want to leave it as a fraction, so we leave that 1 on the bottom. Now we build our binomials. All right, so denominator in front of the x, give us 2x, followed by the numerator, which in this case is a negative 1 minus 1, so 2x minus 1. And then we're going to have a 1 in front of the x. We don't have to write the 1, we just call it x. And then followed by the numerator, which is a positive 11. So 2x minus 1, x plus 11 would be our factored form. All right. Next one, 8x squared minus 14x minus 15. All right, so our A is 8, B is negative 14, C is negative 15. Figure out A times C, which is going to be 8 times negative 15, which is actually going to give us a fairly large number, negative 120. All right. Now, I did not leave quite enough room for us to go through all the factors of negative 120, so I'm going to go to a blank sheet of paper here to work through that on. So negative 120, factors of negative 120, there's actually a lot of them. So, and it's negative, so we need one positive, one negative. So negative 1 and positive 120, positive 1 and negative 120, negative 2 and 60, to a negative 60, negative 3 and 40, positive 3, negative 40, and we can do negative 4 and 30, 4 and negative 30. We can go through 5, negative 5 and 24, or 5 and negative 24. 6 will go into negative 120. So negative 6 and 20, or 6 and negative 20. 7 won't go in, but 8 won't go in evenly. Let's see, 8. Yeah, 8 and 15, right? Which is actually how we got this number. So negative 8 and 15, or 8 and negative 15. We can do 10 and negative 12, or negative 10 and 12. All right, so lots of factors. But we're looking for the set that we can add together and get our B term, which is, from the problem, negative 14. So, looking for negative 14. So this is going to be 119, negative 119, 58, negative 58, 37, negative 37, 26, negative 26, 19, negative 19, 14, and negative 14. So there's what we're looking for, negative 14. So we've got 6 and negative 20. So 6 and negative 20 are the factors. Add up to equal negative 14. So now we make those into fractions. 6 and negative 20 over the A term, which is 8. Reduce the fraction if we can. 6 over 8. Both of those divide by 2, which is going to give us 3/4. Negative 20 over 8. Both of those terms are going to divide by 4, which will give us negative 5 over 2. Now we build our binomials. Denominator in front of the x. So 4 in front of the x, followed by the 3 plus 3. Denominator in front of the x, so 2 in front of the x, followed by the denominator, or the numerator, which is negative 5. So 4x plus 3, 2x minus 5. All right. Next one, 6x squared plus 9x minus 27. Now, as these numbers get bigger and bigger that we're dealing with, one thing that you'll want to look at is there a number that will go into all three of those numbers, which 3, 5, and 2, those are all prime numbers. Can't simplify those any. 2, 21, and 11, so 2 doesn't go into any of those. 8, 14, and 15. 8 and 14 you can both pull a 2 out of, but not out of 15. Now we have 6, 9, and 27. So all three of those actually could be divided by 3, right? So when we factor, if there's a number that'll go into all of them, we can pull that out to begin with and put that in front. And now 6x squared divided by 3 would actually become 2x squared. 9x divided by 3 is 3x. And negative 27 divided by 3 would be negative 9. So now don't forget we have this 3 here because we'll need that in the final answer. But now we're just going to focus on the trinomial to factor what's left. So a term is 2, b is 3, and c is negative 9. So if we do our a times c, it's going to be 2 times negative 9, which is negative 18. So positive, negative, plus minus means one's positive, one's negative. And now if we look at the factors of negative 18, we've got 1 and negative 18, negative 1 and 18. Do 2 and negative 9, negative 2 and 9. 3 and negative 6, or negative 3 and positive 6. Add them together. 1 and negative 18 is negative 17. We're looking for 3. That's not it. Positive 17, that's not it. 2 and negative 9 is negative 7. Not it. Negative 2 and 9 is positive 7. Still not it. 3 and negative 6 is negative 3. Close, but still not it. And negative 3 plus 6 is going to give us 3. So there's what we're looking for. So our factors, negative 3 and 6. So negative 3, 6. Build our fractions. Put in front of the a term, which is the 2. So negative 3 halves, we can't simplify that any. 6 over 2 can become 3 over 1. So build our binomials. So denominator in front of the x, so 2x. And it's negative 3, so minus 3. And then 1 in front of the x, followed by plus 3. So 2x minus 3, x plus 3. So that's the trinomial factored, but don't forget that we had that 3 right here. We still need that to be there, so put that all together, and that's the factored form. 3 times 2x minus 3 times x plus 3. Alright, so then the last one, or last type of problem, tells us once you factored a trinomial into 2 binomials, then we can use those 2 binomials to solve the equation. So all these up here were just relations. We didn't have an equal sign in them. But if we have an equal sign, then once we factor it, then we're going to have to set those factors equal to 0 and solve. So first thing we have to do, if we have a quadratic, is in order to solve it, or to factor it here, we need it to be set equal to 0. So we're going to move 12x over and 10. So subtract the 12x from 10x. Subtract 10 from negative 11. And so now we're looking at 8x squared minus 2x minus 21 equals 0. So in order to solve this, we want to factor it. And we have a number in front of the x squared, so we're going to use this ABC method. So our A term is 8, B is negative 2, and C is going to be negative 21. Big numbers, so if we could factor anything out, we would go ahead and do that. 8 and 2 are both even. We could pull the 2 out of those, but 21 is not even, so can't factor anything out of it. So we're going to do our A times C, which is going to be 8 times negative 21, which is going to give us negative 168. And negative 168 is a big number. Probably going to have a lot of factors. So just to make sure I don't run out of room, I want to go to my extra sheet here to factor that. So factors of negative 168. If we look at those, at negative 1 and 168, 1 and negative 168, 2 and negative 84, negative 2 and positive 84, 3, negative 56, negative 3 and positive 56, 4 and negative 42, negative 4 and positive 42. Then 5 won't go into negative 168, but 6 will. So we can do 6 and negative 28, or negative 6 positive 28. Do 7 and negative 24, negative 7 and 24, 8 and negative 21, negative 8 and positive 21, 12 and negative 14, or negative 12 and 14. And then we're going to add to find the ones that add together to equal our B term, which our B term that we're looking for, back to our sheet, B term is negative 2. So negative 2 is what we're looking for, the difference, or the when we add them together. And when we look at the huge number differences, we know that's not going to give us a difference of just 2. Actually come down here, 12 and negative 14 is negative 2. That's what we're looking for. So 12 and negative 14. So 12 and negative 14. Make them into fractions over the A term, which is 8. Reduce the fractions if we can, which we can. 12 over 8, both divides by 4, give us 3 over 2. Negative 14 over 8, both divides by 2, so negative 7 over 4. So now we're going to have the denominator in front of the x, so 2x, followed by the numerator, plus 3. Denominator in front of the x, 4x, followed by the numerator, negative 7. So that's the factored form. 2x plus 3 times 4x minus 7 equals 0. Now that it's factored, we can use those factors to solve. So we set each one of those binomials equal to 0. Subtract 3 from both sides. 2x equals negative 3, and divide by 2. So x could be negative 3 halves. Then for the other one, 4x minus 7 equals 0. Add 7 to both sides. 4x equals 7, divide by the 4. And x equals 7/4. So x could be negative 3 halves, or it could be 7/4. And that is section 10.6.